So hi everyone, you can see this is the experimental arrangement for the experiment on dispersive power of prism. So in this experiment we have to find out the dispersive power of a material of given prism. So the apparatus required for this experiment are mercury vapor lamp, spectrometer, prism. Two sides must be transparent and one side must be opaque, and this is the prism table. So here we have the two vernier scales V1 and V2, and in the previous video I have explained how to use the spectrometer, you can watch that. And this is the collimator, and this is the telescope where we can observe the dispersion from the prism on the left side or right side. So first we should know what is dispersive power. So the dispersive power we can define it as the ratio of the angular dispersion for any two wavelengths of the deviation of mean wavelength is called dispersive power of the prism. If we consider the dispersion of light into 7 colors, then we have to consider 3 colors. The ratio of the angular dispersion for any two wavelengths to the deviation of mean wavelength is called dispersive power of prism. So here is the formula, so you can have the idea. So dispersive power of the material is given by omega equal to delta 1 minus delta 2. These are the minimum deviations for two wavelengths, lambda 1 and 2, and we have to take the ratio of these two wavelengths difference to the delta 3, that is angle of minimum deviation for the ray of light with mean wavelength. So this is the formula to calculate dispersive power. So when light passes from the prism, we will observe the dispersion of light. So here we can consider the three colors, violet, yellow and red. So lambda 1, lambda 2, lambda 3. So dispersive power we have to find out delta 1, delta 2, delta 3. So here is the tabular column. First let us, once light passes from the mercury source to the collimator, then it falls on the prism. So when light falls on the prism, the light splits into 7 colors, VIBGYOR as we can say. So once we observe the spectrum from telescope, then we should note down. So we should note down the vernier scale reading here. From this is the, there are two windows V1 and V2. So for window V1, when we move the telescope towards right side, then you should note down V1, and when you move telescope to the left side, then we should note down the vernier scale V2 from window 2 for the 3 selected colors we have to observe. So without keeping the prism on the prism table, you should note down the direct ray reading for different colors. So the direct ray reading is going to be same for all the 3 colors. If you take left side, it is going to be same. When you move to the right side, the direct ray reading is going to change, but that is fixed. So direct ray reading you should take without keeping the prism on the prism table. So here we have to note down the traveling microscope reading for 3 colors, violet, green, red. And here is the mean deviation position A. That is we have two windows here, V1 and V2, vernier V1 or window A and B we used to call.
So you should write here the reading for vernier scale reading. Minimum deviation position, you can consider it as small a, and for each time you should note on the direct ray reading, means without keeping the prism on the prism table. Directly you should observe from the telescope and note on the vernier scale reading. So here is the minimum deviation position and direct ray reading for all the three colors. So next you have to go to window B. This is for window A. So window B, you can consider it as vernier scale reading V2, minimum deviation position as C, and direct ray reading D. So once you note down the minimum deviation position for movement of telescope to the right side or left side, considering the window A and B or vernier scale reading V1, V2 for three colors, violet, green, red, then you can calculate here the difference between the vernier scale reading. V1 is equal to A minus B, minimum deviation position A and C. You have to subtract, you will get V1. V2 reading, that is for direct ray. Without keeping the prism on the prism table, you should note down direct ray reading. So once you subtract, you will get V2. Then take the mean of these two vernier scale reading, V1 plus V2 by 2. Once you take the mean, you will get the that is the deviation for the three colors, different colors. Then using formula you can calculate the dispersive power of prism.